Okay, so I want to talk about the conceptual idea of using randomization to do hypothesis testing. And to do this, I'm just going to show you some stuff in R, not because I expect you to know R, but because it's the easiest thing for me to show it to you in. So remember this example about the rail trails in Massachusetts where we were trying to predict how many people were on the rail trail based on the average temperature on that day? So if we wanted to do randomization to see if this slope was truly different from 0, we would need to create the situation that would be the case if there was no relationship. And so the way that we do this is we randomize one of the variables. So in this case, I'm going to randomize the average temperature variable. So I'm going to make this new variable, which is called average temp randomized. So you can see that instead of saying 66.5 with the 501 volume, it now says 60 degrees and 55 and 74. So these are all numbers from average temp, but they've just been randomly assigned. So I mixed up all the values of this variable and I created this new variable. And now I can make a plot that shows the relationship between volume and my random average temperature. So watch the slope of the line. So this is the real version of the data. And now here is one randomized sample. So it looks like there's a slightly positive slope when we randomize the data, but it's not nearly as positive as it was in the real data. And then I could do the randomization again. So I could make a new version of my randomized data. So now that first one has 78 degrees and then 46 degrees, etc. And I could do the plot of that randomized data. So again, watch the slope. This one also a little bit positive. And I could randomize the average temperature again, and I could do the plot again. So this one has a slightly negative slope. So the data is the same. I'm just breaking the relationship between average temperature and volume by mixing up the values of average temperature. So that's how I do randomization. Let's go look at it in StatKey. All right, so we're on StatKey, and if we were going to be trying to do that randomization with the rail trail example, that would be a randomization hypothesis test for slope or correlation. So I could go here, and then I would need to upload some data. I think I've done this in the past actually, and shown you the randomized version of this. So let's see, let's find my predictor, trying to predict by temperature based on volume, okay. And if I click generate one sample, StatKey is doing the same thing that I was doing in R. It's mixing up the values of one of the variable while leaving the other one the same. So I'm getting this slightly negative slope, or a slightly positive slope, slightly negative, slightly positive. It's just going back and forth, and I'm building up this randomization distribution. Oh, I should have been doing slope here. I could generate 1,000 samples or another 1,000 samples, and this would be my randomization distribution. So if the null hypothesis were true, I would often find slopes that were around 0. We saw a slope that was 4.8. That would be way out here. It would be really weird. Okay, so let's go back to R and think about another scenario. So in this case, this is the relationship between the pain that people reported feeling and whether they listened to an audiobook or music or a control. So this was a bunch of means. We were doing ANOVA in this case. And let's look at a visualization of that data. We had the box plots and we were saying, okay, it looks like these boxes are, somewhat different from one another. If we wanted to do randomization, what we could do is we could mix up the values of the scenario and leave the pain variable the way that it was. So let's try that. So I'm going to mix up those values, and then let's look. Now I have this new variable scenario randomized, and so this person has been randomly assigned to have music, control, right? So if there was no relationship between these variables, this is one of the scenarios that we could see. We've broken the relationship between those two variables. And now I could make a plot of what the relationship would look like between the real pain scores and then the mixed up scenario values. So here's what that set of box plots looks like. I think that it looks less different than the real data. It looks a little bit different to me, but I could randomize my variables again. So now this person has been randomized to audiobook. They actually had audiobook. This person randomized to control, etc. And we could make that plot again. Whoa, those look pretty different. So I could do this many times, mixing up the values of the scenario and looking at the relationship between those three categories. So let's go back to StatKey and see the corresponding version. So here, that would be ANOVA for difference in means. And again, I would need to upload some data because it doesn't come automatically in StatKey. So if I upload this data, I need to select the quantitative variable and then the categorical variable. And this would show me the table with the sample sizes, the means, the standard deviation. So it's not showing me my whole data set, but if I generate one sample, what StatKey is doing behind the scenes is it's mixing up the values of one of those variables, like that scenario variable, and then it's computing the means for these new groups and computing the F statistic. So in this case, it found an F statistic of 0. I could do it again and again and again, or click 1,000 samples, or click that again, and this would be my randomization distribution. So if there was really no relationship between these two variables, these are the sorts of F statistics we would observe, and we actually saw one that was 5.02, something like this. That looks pretty weird to me, so I would probably reject the null hypothesis. Okay, let's do one more example. So let's think about that data that I was talking about with the relationship between political affiliation and whether the people thought that they were getting the info they needed from the media about COVID-19. So this is a pretty big data set. I've got 8,128 observations, but I could sort by party to see the different parties and the people who have the info I need or not. And just like with these other examples, I could see some type of visualization of the relationship. So let's look at the real data. So here's what the real data looks like. If I'm looking at the relationship between these two variables, it looks like it's about 50-50 for yes and no for conservative Republican, and then the percentage of yes goes up as you move to be more and more liberal. So I see a pretty clear relationship between these two variables. I would expect to find an association between them. But let's see what it looks like when we break the relationship between party and the response, the info I need response. So I'm going to make this new variable called party randomized, and this is where I've just mixed up the values of the party. I still have the same number of each of them, but this person has been mapped to a liberal Democrat, moderate Democrat, liberal Democrat, right? It's just been randomly assigned. And now I could make a plot of that randomized data. So if I do that, okay, now it looks like the percentages are about the same across the board. Maybe they're a little bit different here and here, but they look pretty similar. And then I could randomize that data again. So now this person has been mapped to a moderate Republican, this person to a conservative Republican, and I could visualize that data again. Okay, now this category looks a little bit different, but not very different, and I could do that multiple times. So that, again, that's what StatKey is doing behind the hood. Let's go and do it in StatKey. So for this one, that would be a chi-squared test for association. And like always, I would need to upload the data because I made up this example. So I'm going to pick my variables, okay. And then it's going to count things up for me. If I generate one sample, it's going to be mixing up the labels for the political party, and then finding the counts in each of these categories, and then computing a chi-squared statistic. So if there was no relationship, this would be a chi-square statistic that you could find. And again, I could generate one sample, or I could get lazy and generate 1,000 samples or another 1,000 samples. And then I would look at where is my observed sample statistic, my chi-squared 954. That is so far off the chart, it is crazy. That would be extremely rare to observe if the null hypothesis were true. So that's the main idea with randomization. You keep one of the variables the same and you mix up the values of the other variable, and then you compute the same statistic you had found using your real data. So that might be an F statistic or a chi-square statistic, or it might just be a mean or a difference of means or a proportion, difference in proportions, or a slope. and then you're going to do that many times, and you're going to see what that distribution of statistics looks like under the null hypothesis. That's our simulation method for randomization.